In this video, we're going to talk about the difference between even and odd functions and some of the characteristics they might have graphically in a table and how to determine it from an equation. And so what I have here is I have two examples of functions that are even and odd functions respectively. And so we're going to start with looking at an even function like the function y equals x squared. And we'll just start off by filling in a table. And so I get the output values of x squared from the table. We're going to get 4, 1, 0, 1, and 4. And then we're going to graph those points on the grid. And so looking at this graph, we see that this graph has symmetry, and it is symmetric about the y-axis. So y-axis symmetry. Now here's the thing to keep in mind. All even functions will be symmetric about the y-axis. So I can fold all these even functions over the y-axis and they'll lay on top of each other. Now what I want to note here is let's look at 2 points. Let's look at the point on the graph at -2, 4 and +2, 4. So f of -2 equals 4 and f of +2 equals 4. Now for even functions, there is a property that lies within the functions such that if you put in a negative x value, there's a property that exists for even functions where in a table it's easy to see, and also if you're working with the function algebraically, if you put in a negative x or a negative x value into a function and compare its output with the same x value but positive, they will equal each other. And so that's our algebraic test to determine if a function's even. Now let's look at an odd function. Y equals sine of x is an example of an odd function. Now if I go into my table and fill in my table based on sines values, and I have some unit circle values here, and we can take these values and place them on the graph on the right. So sine of negative pi is 0, negative pi over 2 is -1, sine of 0 is 0, sine of pi over 2 is 1, and sine of pi is 0. And then I go plot those points on my graph. So here we have the graph of y equals sine of x. And I look at the kind of symmetry that exists here for the graph of y equals sine of x. And the kind of symmetry that exists is I would have to fold that graph over both the x and the y-axis in order for it to lay on itself. We call that origin symmetry. So if you see a graph that has origin symmetry, so you got to fold it over both axes in order for it to be a true reflection, it is going to be considered odd. Now, the way to determine the algebraic test for an odd function is similar in terms of what we just did for the even function. And I'm going to pick out 2 values here. So I'm going to pick the table value of pi over 2, so f of negative pi over 2 is equal to -1, and I'm going to pick positive pi over 2, so f of positive pi over 2 is equal to +1. And we compare the input values to the output values, where they look very similar except for one part. F of pi over 2 is equal to -1 times f of negative pi over 2. So algebraically, our test for to determine if a function is odd or not is if I put in a negative x value, it should equal the same thing as if I put in the positive x value, but I changed the sign. Okay, let's do some examples here. Got a little variety for trying to determine if a function is even or odd or neither. So we'll start here with the table. And I'm looking at a table of values. And so one of the things that you try to do with a table of values and when you're determining even or odd functions is you're looking to see values in the y column and determine whether or not any of these y values start to repeat one another. And so I see negative square root of 3 over 3. I see positive square root 3 over 3. I see negative 1, and I see positive 1. So I'm starting to see a repetition of values, but the difference that I see is they have a change in signs. And so I'm going to do the even or odd test. I want to know and compare when I put a positive x value in to when I have the same x value but negative in. So f of pi over 4 was 1, f of negative pi over 4 was negative 1. And so when I have a negative x value in and compare it to the x value when it's positive, all I did was change the sign. By definition, that function is odd. Now let's look at a graph and graphically try to determine whether or not a function is even or odd. So to determine from a graph if a function is even or odd, you got to look at the symmetry. So what kind of symmetry does this graph have? Well, it has y-axis symmetry. If a function is symmetric about the y-axis, it is even. Now let's look at an equation. F of x equals 0. Well, how would I do the even or odd test with an equation that has no x's in it? And in fact, I try to think about, well, what does this thing look like graphically? Well, graphically, if I had my x and y axis, try to change colors here, the graph f of x equals 0 lies on the x-axis itself. So graphically, what kind of symmetry exists for the line y equals 0? Well, it has y-axis symmetry, and it has, technically if I fold it is the x-axis, so I could say it has x-axis symmetry. And it is also, if it's symmetric about both the y-axis and the x-axis, it's also, in this case, symmetric about the origin. So that wasn't one of the initial node examples that we had at the very beginning of this video. In fact, this is, y equals 0 is the only equation that is both even and odd. It's the only function that meets both requirements. Now let's look at another equation that has some variables involved. And if I want to determine whether or not the function is even or odd, I got to do the even or odd test. So the even or odd test is change all x's and put a negative x in its place. So if I put a negative x everywhere I see an x, and I rewrite my problem, I want to know what effect did that have on the equation. Well, so we'll simplify. Negative x to the fifth is the same thing as negative 1 times x to the fifth power, minus negative x being squared, so that's going to make minus x squared, and then minus 3x. And I look here and say, well, I need to answer this question. Does f of x equal f of negative x? And the answer is no, it does not equal, because the signs are different. So therefore, I know it's not even. And the second question we ask ourselves is, okay, does f of negative x equal negative 1 times f of x? And we go through and we look for a change in the signs. And the issue that we have here is all the signs are opposite except for this one, which means it is not the same thing as me multiplying my function by a negative 1, so I know it's not odd. So that means it's neither. Now let's look at this one. We're trying to do the even or odd test. So the even or odd test means we change all x's into a negative x, and then we simplify the equation to see what effect that had on our expression. So I put a negative x in parentheses everywhere there was a positive x. I rewrite, and then we go through the process of simplifying. So that's going to make x squared on top divided by negative 3x to the third plus x. So that's f of negative x. Now, looking at where that negative is, I could help myself out with this test and say, all right, technically the whole bottom is being negative. It's the same thing as if I multiply the entire fraction by a negative. So it'll be x squared over 3x to the third minus x being times by that negative out front. And so the even odd test here, if I look, and so I look here at what I have highlighted, I basically have f of x just being multiplied by a negative 1. And so according to our even or odd test rules, if I put in a negative x and that equals negative 1 times my original function of x, that is by definition an odd function. And last but not least, the function of x is equal to cosine of x. And without using any trig identities here, to do this, we would have to look at a graph of cosine. And if I go from, we'll go from 0 to pi, and we'll also go backwards to negative pi. And we'll have to use some unit circle knowledge. So cosine of negative pi is going to be negative 1. Cosine of pi over 2, or negative pi over 2 is 0. Cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is negative 1. And so graphically, cosine actually would have a little bit of a bend right there. Would look like this over that interval, which has y-axis symmetry, which means it is an even function.